morning and welcome back to another video. Today I'd like to show you how simple it is to stand up an RSocket server using Spring Boot and deploy that server to AWS using EC2 so that that server can be accessed from anywhere in the world. As a quick reminder, everything you're about to see in this video is also accessible from my website hbrown.dev. There's a link to the entire article explaining everything that you're about to see, and most importantly at the bottom you'll see not only all the commands that I execute on EC2, but you can also get hold of a link to my GitHub repository, which will give you all the code that I'm about to show you, and you can simply clone this project and then get access to the all the code that you need and then build it from there if you want to deploy this onto your own AWS EC2 instance. So without further ado, let's pop on over to have a look at what RSocket is. So essentially, RSocket is an application protocol that was initially developed on Netflix, is now open source. And where it really stands out is that it allows you to do more than simply request response like HTTP. So it allows you to, for instance, do a single request and then stream results over to your connection. So you make a single request and then you get multiple, or you get a stream of results coming back down to your client. You can also do fire or forget, where, for instance, you want to notify a server of a particular event, you can fire a request and you don't need to wait for response. You can move on with your life. And if you have two-way communication where you, for instance, want to update a server with your latest information and the server can send back results based on that information, you can also have a bidirectional stream. And of course, you can head over not only to the Wikipedia page, but also the rsocket.io webpage to see and read all about that. So let's get started as we usually do with Spring Boot over at start.spring.io. And I'll just show you how I created the project. I chose a Gradle project. I'm using Kotlin version 2.4.4 as the latest. I filled in my project metadata. I'm building a jar file using Java 11. And the only real dependency I needed was RSocket, which you can find under the messaging tab if you want to create the project yourself. So that's where I'm going to get started. I've already created that project and downloaded it. So I'll just take you through what my build file looks like. You can see all the plugins that Spring Initializer will create for you, and you can see all the dependencies that it will put in your dependency block. The only dependencies I've added is the strict dependency over here. That's not strictly speaking needed, but I will use that as my assertion library for the test that I write. And other than that, it's a stock standard build file as you would get if you followed along from Spring Initializer. Okay, so now that we've got the build file, as usual, we'll create a controller. And if you've ever used Spring MVC to build either a web page or a RESTful API, most of this should look quite familiar to you. So you create a controller, and to do that, you specify the @controller annotation. And unlike if you were building a web page or a RESTful API where you might use something like @request mapping to specify the path to access, in RSocket, the way we do that is by using the @message mapping annotation, and we can then specify the path to be able to access our function. So that should look pretty common to you if you've used something like Spring MVC before. Of course, we can use dependency injection as we normally do with Spring to inject any dependencies that we have. Okay, what I've created to demonstrate this functionality is I've created a contacts database with some hard-coded contacts in there that we can search for using a DTO that you've specified. So if we first have a look at what a contact looks like, in this case, a contact is simply has some ID, which is optional. It can be null. It has a first name, a last name, a mobile number, and an email address. And then to simulate an actual service that might be able to do the search, I've created a contact service interface and implemented that with some hard-coded test data. As you can see here, I've just got 4 entries in my pretend database, which is simply a concurrent map in which I'm going to store all of these entries over here. And I just created some test data over there. And then the implementation of my search is also not very interesting. It works off from a DTO called search criteria, which if I head over there, simply allows you to specify some optional parameters such as a name, a mobile number, and an email, since those are the things I want to be able to search my contacts database for. And then all I do is I simply loop through the list of values in my in-memory map, and I check if the first name contains the name you specified. Of course, I'm ignoring case, or the last name, or the mobile number, or the email, depending on which you've set on those search criteria. So nothing very earth-shattering in this implementation of my contact service. And just to make sure that it actually works, I've got a Spring Boot test over here that runs against that service. So I've annotated this with a Spring Boot test and auto-wired in that contact service. And then I simply run a couple of tests to make sure that if I search, for example, by a name called Brian, that I get a result which is not null, and there's a single entry in my list that gets returned, and the first entry has an ID of 2, which if I go look back in here, you should see makes perfect sense. So if I look back at this, you'll notice that one of the things about working with RSocket is that it uses the reactor project underneath. So all the results are based on Flux and Mono, which if you haven't used it before, can take a bit of getting used to. So essentially what I do is I'll can run this test now so that we can just have a look at the test results. Okay, and if I just select one of these test results, we should be able to see what's going on. You'll notice that, as I mentioned, it's using the reactor project underneath, and we can see the steps involved. We can see that we subscribe to that flux and we request an unbounded number of elements to be returned, and we get a single call on next, which gives us the contact that we expect. And then from that, because it's the only result in there, you can see that the flux ended or called complete, and so we get the results that we expect. Okay, and that is basically all there is to this contact service. Now if I head back to the contact controller, all that happens in the contact controller is that the search method delegates to that contact service that you've seen, passing in the search criteria that was passed along to it. And in the project, there's also a test to make sure that we get the same results from our controller. The only interesting part in this test is how we actually connect to that RSocket server. So one of the things that we can ask Spring to do is to inject the RSocket requester builder, and that gives us a builder that we can use to connect to our RSocket endpoint. We can use the @local RSocket server port annotation to ask Spring to inject the port number on which the server has started up, and then we can use those 2 bits of information to actually build a RSocket requester object. Once we have the RSocket requester object, we can then use it in a very similar way in which we did in our service. Essentially, we can, on the requester, we can specify a particular route that we want to send our request to. We specify the data that we want to send to our method. In this case, we're creating a search criteria object, and we're trying to search for by a name that contains the word Brian, and we then ask it to retrieve the result and map that to our contact object. The long statement simply allows us to see nice output for all the various states that we go through, which you've seen when I ran the service test, but that will allow us to see the subscription, how many elements get requested, what is returned on the flux, and when complete is called. And then finally, I convert the flux that I get back into a list, and I wait until that list has been populated with all the elements from my flux. And then I run an assertion on that list to say that it shouldn't be null. Again, it should have a size of 1, and the first element has an ID of 2, which, as you've seen in the test data, is the case. So if I run that test, we should get a result that passes, and in fact the test looks very similar and has exactly the same result as you've seen when I tested the service itself. So that is all there is from a coding perspective. From a Spring Boot perspective, the only other thing that is required in order to stand up this RSocket server is configuration inside of my application.properties file. And the only configuration that is required to stand up the server is to actually specify the port on which my RSocket server should listen. And you do that by specifying the spring.rsocket.server.port and setting that to a free port value. And that is all that Spring requires to be able to run this application. In my particular application, you can see I've also specified some logging configuration, and then also I've enabled lazy initialization. None of this is needed in order to get the Spring test to run, but it is useful if you want to see some logging. So that's what I've specified. Once you've done all of that, of course, you can use your IDE to run this application. And what you should see is that the application starts up and then starts listening for requests coming in. One tool that is quite useful in order to test RSocket is called RSC. And if you download the code, what you'll get is you'll get something in the README that will give you the link to go and see that RSC tool that can be used to hit a RSocket endpoint, as well as the commands that you need to do. In fact, let me run the server again. And then while the server's up, we can actually run it against our local server to make sure that it is working. So I won't go into the details of using RSC. For that, you can see the web page, but I will show you some of the data that I've specified. So let's start with this name, and you can see it's a simple JSON document, which, much like in our test, just specifies a name of Brian. So in order to run that, I can just head to my README. I can copy that command over there, and if I open up my terminal, I can paste that command in and run it, and you should be able to get some output. And you can see, as promised, RSocket is a binary protocol, so it will show you all the values and how they were mapped, and you can see exactly what is going on, and that is thanks to using this debug flag as part of RSC. But what you can't see over here is the difference between the request response type of interaction and what we've actually implemented over here, which is a streaming response to our request. So if I run another example over here using this multiple search.json, in which I've got two parameters, so looking for any mobile number that contains the value 3 and any email address that has the value co.za. And if I head back to our contact servers and have a look at the test data, and see that there are a few mobile numbers that contain the number 3, and then there's exactly one other email address that has the letter co.za. So if I take that request and paste that request in, I should mention that I'm also just piping the results through JQ, so we get a bit of a nicer output. And I run that, you'll see that what we get is multiple responses, but what you'll notice, this is not a single JSON document. You'll notice there's no commas separating each of these things. So what we actually got was a response that contained 3 separate items, the first one being the first result, and then the second result and the third result as 3 separate items, rather than one single response containing all of the items. So if there was many more items, then of course this would be a much more efficient way of getting that results, rather than waiting for all the results to be available and then sending all of the results as a single document. Okay, as an RSocket server, the reason why we are getting that response as a stream rather than as a single response object is because of this return type over here, which I've specified as flux. If I wanted to create this as a single response, then what I would have used is something like a mono, and then specify that what it would have gotten back would be a list of contacts, and that would give me then a single response back with the entire list of contacts as a single element. In this case, I'm asking the RSocket server to stream the results back to me because I've specified flux as my return type. Okay, so that basically wraps up how we create and stand up an RSocket server. All the code that is required, which you can see is actually very little and very familiar if you've used something like Spring MVC before. And the configuration is also quite minimal. The only thing required is the spring.rsocket.server.port value in your application.properties, and that should be enough using Spring Boot to create an RSocket server. The next thing that I'd like to show you is how we can go about deploying this entire server onto AWS and making it accessible via an EC2 instance. So to do that, I will use the console management tool from AWS. So if you haven't got if you don't have an AWS account, then you'll need to go ahead and create one. And once you've created one, you should be able to log into your AWS management console. Make sure that you are in a region where you want to deploy this thing, and then you should be good to go. Okay, so the first thing you want to do is you want to head over to services, and under the compute section, you should see a link to an EC2 instance. So if you click on that, you might be confronted with something like this if you've created previous EC2 instances, or you might see a dashboard if you've never ever created an EC2 instance, and then also some supporting documentation which you can read through. In order to create a new instance on EC2, you'll have to click on this Launch Instance button, and this will create a new EC2 instance in the region that you've selected. Because I'm in Cape Town, I've selected the Cape Town region, and essentially we will be creating an on-demand instance, which allows us to create an instance and shut it down without needing to commit to any time period for which we want to use this instance. And since I'm only going to be using this instance in this demo, that is perfect for our needs. So I'll click on Launch Instance over here, and you'll be confronted with a bunch of AMIs, which is essentially specifies the host system that you want to be using for this demo. I just want to remind you again that I'll be running quite a few terminal commands. So if you want to copy and paste those terminal commands, all of them are available on the website, and you can just follow along using that and just copy and paste all of the commands that I'm about to show you. Okay, so for this demo, I'm going to select this top one, which is free or is eligible for the free tier on Amazon. So if you've signed up, Amazon gives you some things for which you won't pay, and this is part of that. So I'll just go ahead and select that. The next page that you'll be confronted with is to be able to choose an instance type, which is basically how much resources should be allocated to the virtual machine we are about to build. And you can see that the T3 micro is free for the eligible tier, so you could select that. But since I'm only going to be using this for a really short while for this demo before I kill it, I'm going to be a bit more adventurous and select something a bit larger, maybe not quite that large, but I'll select this T3 large instance. At this point, I could hit this review and launch button over here, which will effectively launch my virtual machine. But because there's some additional configuration I want to do, I'll take you through the next steps. So if I then click on the next button over here, I'll be given an opportunity to set up some networking information. I'll be able to specify a placement group. So if this was a service that needed to interact with other services, I could specify how I wanted those other services and the services to be placed on the hardware. But since I'm not really interested in any of those things or specifying additional CPU options, I will leave the defaults for all of that and simply click next to get to an option which allows me to add additional storage onto my virtual machine. In this case, we can see that the root file system is a 8 gig general purpose SSD, and for our purposes, that is more than enough. So I won't do anything over here. I'll simply click on next. Okay, I'm then given an opportunity to add some tags, which is essentially key value pairs that can help me find these virtual machines or any resources really on AWS if I've got lots of them in future. But since I plan on killing this immediately once the demo's done, I'm not going to bother adding any tags. And then the real reason why I've come through all of those configuration pages is to be able to get to the security group. So you can see by default, the security group that is automatically applied has a single type or has a single rule which allows SSH access on port 22, and the default is to allow it from any IP address. Of course, if you know the IP address from where you're going to be accessing, it's a good idea to limit access into this just to make it more secure. But for the purposes of this demo, that's not enough because we also want to access our RSocket server over TCP. So what I'm going to do is I'm going to click the add rule. I'm going to leave this as a custom TCP type over here. I'm going to specify a port range. In our case, that'll be port 5000. And I'm going to specify that this should be accessible from anywhere. Again, if you know the IP address of where you're going to be accessing the servers from, you can lock this down a little bit by specifying that IP address over here. And I'll type in a description such as, I don't know, RSocket Server or whatever else you want to. Okay, and then we can see again AWS warning us that these rules mean that port 22 and port 5000 will be accessible from anywhere in the world. Once you specify those two rules, you can click review and launch, and AWS gives you a summary of all the options that we've chosen so far, and I can go ahead and click launch. The final thing you can see is that AWS allows you to create a new key pair which can be used to access this virtual machine. So if this is the very first time you're doing something like this, you might want to create a brand new key pair over here. But if you've done this before, you'll probably have a key pair available over there. And in that case, you can just select the key pair that you want to use to access this virtual machine. Because I've already got a key pair, I'll just leave that one selected, and I acknowledge that I'll be able to use this key pair to be able to access this instance. Once I've set up a key pair to be able to access this instance, I'll click the Launch Instances button, and AWS will go away and start configuring that virtual machine for me. And I can go back to my dashboard by clicking this View Instances button over here. What you'll notice on this button on this page is that it'll take a little while for your virtual machine to launch. Before it is ready, you'll see in the status check, you'll see a status of initializing. And once it's up and running, you'll see a value called a value over here that says running. Okay, you can also click on the instance ID to get more information about it, and you can see the instance state from here. You can see the public IP address and also a public DNS, which you can use to access the server. If you scroll down a little bit, you'll see some further details about it. You can access your security, your networking, the storage, and all the other parameters that you chose while setting up the server. The button that you want to click, however, is this one on top over here, which says connect. So if I click on that, what you'll get is you'll get some information about how you can access this EC2 instance. So it'll tell you that that key that you downloaded, the private key that you downloaded to your machine, or if you didn't create one, if you selected it, should not be readable by the world, and it'll give you a command to run that command. You can simply click that button and it'll copy that command so that you can make sure that your private key is not accessible to the world, and that's important. If it is, what you're about to do won't work. Okay, then the next thing you'll need is you'll get a public DNS that you can access the server by, and as well as an example of how to access the server using SSH. And again, if you click on the little icon next to it, it will copy that command over for you. Okay, so now I'm going to head back to the terminal, and we will use the information that we've got so far to be able to access that terminal. Okay, here we are. I'll open up a terminal again. I'll just clear my last command that I ran, and we should be ready to go. Okay, so I'll just paste in the command that I got earlier from, well, that didn't work very well. Okay, let's try that again. So what I'll do, in fact, is I will head over to my README and just copy the command in here so that I can copy and paste a little easier. Okay, so what I want to do is, this is the command that I've pasted from copying over on AWS, and my pen file or my private key is not going to be in my current directory, so I'm just going to append the path where I know my private key is, and so you should be able to do something similar to wherever you downloaded your private key. And I know that the user with which to access this is also not the root user, but is a user called EC2 user. And so once that is ready, I can copy that command and then go back to my terminal, paste that command in, and run that. And if it's the first time you're connecting to it, you'll see a little warning like this, and you can just type in yes. And that should give you access to your EC2 instance using SSH. And we can now go ahead and we can run some updates if we wanted to. And that will take a few seconds to run. And so that updates all the packages on this instance. Okay, while that is running, okay, it's actually complete. You can head back over to the blog if you want to, and that takes you through all of the things that you've seen now, including that SSH command. And the next step is to install a Java runtime, and there's various options for doing that, but the simplest one is simply to copy this command over here and then run that command in your terminal window. Okay, and so once you've installed Java, you should be able to run something like Java minus version and get a version of Java that's installed. You can see I've installed the OpenJDK version 11 for our purposes. Okay, so once you've installed Java, the next step is to actually copy over the jar file that you need in order to run the demo application. So here's an SCP command that you can use. And again, I'm just going to copy all of this over. Just copy all of that over, and I'm going to head back to my terminal. And before I actually run that, I'm just going to once again paste that in here, and I'm just going to make sure that the address that I have for my publicly accessible instance is correct. So that is from after the @. I'll just paste that in until there. Okay, and then once I've got that command, I can copy that command and I can head back. Now we've got to be careful. So this has to run on your local terminal and not on your remote EC2 instance. So I'll open up another terminal over here and I'll paste that in over there and I will run that. And what you should see is that that should then copy over that jar file to my remote instance. If I head back to my other terminal window and I check my root folder over here, you'll see that that file has been copied over to this location over here. Okay, so then if I head back over here, you'll be able to once again see the next steps that I've executed. So essentially what I'm about to do is I'm about to just create another directory and then put all of the resources in there to start up my server over here. In fact, I could have just run java -jar command and started up the RSocket server, but I prefer to have a very specific outlay for my project. So I'm going to go ahead and do that in my terminal again. First thing I'm going to do is I'm going to make a directory for myself using mkdir. And once I've created that, I will cd, or in fact, I'll move the RSocket contacts jar into that folder that I've just created. And then I'll cd into that RSocket server over there, and I will just make sure that everything is as I expect over there. And I'll start off by creating some further directories, a bin directory and a logs directory in order to store my logs, and I'll create a file called application.properties, and you can then see, so these are all, I've got my jar file in there, 2 directories, one called bin, one called logs, and a file called application.properties. And inside of my application.properties, I want to copy over some properties from my blog. In this case, it's exactly the same as is in my internal file, but I like to externalize some of the properties, and I'll paste that in, and then I'll save the file. Okay, once I've done that, I want to create a little startup file for myself. So inside of here, I'll create a little startup shell script, and I'll again head over to my blog and just copy and paste the information from there into this file over here. Okay, and I actually think I might have named my folder something differently. So I'll just update this name over here. I think I actually called it RSocket Server. Okay, and that's the command that I need, and I'll save that, and I will make that file executable. So that should allow me to easily start up my server. And of course, I also want to be able to shut down my server. So I'll copy that from the blog post and then move back over here, and I'll create another file, this time call it shutdown.sh, and I'll paste in all of that information over there. And basically that allows me to be able to shut down my server nicely. And of course, I also want to make that file executable. Okay, so now that I've done all of that, I should be in a position to be able to start up my server by simply running, the startup script. Okay, to make sure that that is running, Let's check if the log files is communicating, and we can see that our RSocket server has in fact started up. Okay, so that is great news. We now have a RSocket server that is running remotely on our EC2 instance. And to just make sure that it actually is running on our EC2 instance, what I'm going to do is I'm just going to use RSC to once again run the same command that you saw earlier, but this time against our remote server. So I'm going to head back to the IDE, just paste that command in here so that I can update the DNS with the correct location. And we know that it is running on port 5000. So once I've got the correct location over here, I can head back to my terminal. So I can go to my local machine again and paste that command in, and I can run it, and we get output the same as we did before, but this time running against our EC2 instance. So anybody with this address should now be able to access that service running on port 5000. So we've created an RSocket server and we've deployed that onto EC2, and we've started up the server on EC2. So all that remains now is for us to head back here and shut down all of the things that we started up to do this deployment. So we can start by running the bin shutdown command, and that should after a few seconds shut it down. And just to make sure, if I head back over here to my terminal again and I rerun the previous command, what you'll notice is that we get a connection refused because we've stopped the server running on that port. Okay, so that then brings us to the end of this tutorial. All that I want to show you is how to actually clean up after yourself on the EC2 instance. So if you head back to your management console, click on the instance name, what you should be able to see is that we are, of course, in a running state. And if you click on the instance state over here, you should be able to click on stop the instance. It will ask you to confirm that you want to stop the instance, which you can then click on, and it will change that instance state from running to stopping. And this may take a bit of time before it is actually in the stop state. Once it is in the stop state, you should be able to then head back into the instance state and use the terminate instance to be able to terminate the stopped instance. And eventually, once it has been terminated, you'll see the instance state will change to terminated, and eventually it will be removed from your dashboard. Thank you very much for your attention. Don't forget that you can head to my blog page to copy and paste all of the commands that you've seen me run and be able to get access to the GitHub repository with all of the code so that you can simply clone the repository and try this out on your own. Thank you very much.